Hey kids, let's talk about categories of reactions. And the new one we're going to learn about is acid-base neutralization.
Okay, so we're going to do that one first, but the other ones that we talked about before were precipitation reactions and redox reactions.
Yep.
So let's learn about this, right?
The third one.
Okay. So we're going to start with this reaction. I think this is one of your personal favorites. HCl, which we know is what?
Hydrochloric acid and sodium hydroxide.
Okay, so when you mix these two things together, you have an acid and you have a base, clearly, according to our Arrhenius definition.
Right.
What's it going to make?
Well, one of the products will be water. The hydrogen ion will combine with the hydroxide ion.
Okay.
Well, who said you can't make water?
So this hydroxide ion combines with this hydrogen ion to make water.
And the other product is going to be the sodium and the chlorine will combine.
Okay.
So it'll be sodium chloride.
And chlorine. So how do I write sodium chloride? It's just NaCl, right?
Yep.
I look at the oxidation numbers.
Right. Na+1, Cl-1.
Okay.
Okay, and then here's an easy way to remember this. Okay. A neutralization reaction is an acid plus a base makes water plus a salt. NaCl is a salt, sodium chloride.
It is table salt.
And it is salt.
So any sort of ionic compound that is left over after an acid-base neutralization is a salt of some sort.
Right.
So, but can't some salts be insoluble?
Yeah, let's talk about that too. So sodium chloride is soluble, obviously.
Right.
We throw salt in pasta water to make the pasta taste better, so it dissolves.
Yeah.
Okay, so let's do one with an insoluble salt.
Okay, so that's a neutralization reaction. I think I got one.
Okay.
Let's do carbonic acid and calcium hydroxide.
Okay.
I think that'll work. So I've got
water.
I've got two H's and two OH's here, right? So that's going to give me two waters. And then I'm left with calcium and carbonate.
Which is plus 2 minus 2, so CaCO3.
Plus 2 minus 2, so that's CaCO3.
Calcium.
Now, this is a neutralization reaction, right?
Yep, water plus a salt.
Okay. But it's also, not only is it a neutralization reaction, it's also another type of reaction.
Well, the calcium carbonate, chalk,
This thing
is
right
insoluble. So remember where your solubility rules are. So this is also going to make a precipitate. So it's also going to be precipitation. So they can be two categories at once. You have to check your solubility rules.
So the previous one, we made water and we made a salt, but NaCl was soluble, so it was only neutralization.
Right.
This one, since we made our water and an insoluble salt, it is not only neutralization, but also precipitation.
Right. So why don't we review all three types now?
Okay, so we've got neutralization as our new one. So what do we want to do now?
Let's make a chart. We have redox, we have precipitation, and we just learned about neutralization. So redox reactions were pretty much everything except...
Sorry, hold on. Neutralization, I'm not going to be able to fit it. Neutralization, okay, great.
Okay, so redox was pretty much all the types, except for double replacement.
All types.
So, synthesis.
Except double replacement. Okay, so that means
Synthesis, decomposition, combustion, single replacement. Single replacement, though, remember if they're metals, the activity series is also going to be precipitation.
Okay.
So single replacement is a redox and precipitation.
Okay, so precipitation reactions, single replacement is one.
With metals, right?
So single replacement if you have metals. Okay.
And then double replacement, remember the only way those reactions occur is if they make an insoluble product.
Double replacement reactions, yeah. So those are automatically precipitation because if they happen, they are.
Right.
Okay.
And neutralization, so acid-base neutralization is a specialized type of double replacement.
Okay.
So they are double replacement reactions, but they're ones with an acid plus a base that produce water plus a salt.
So I'll say acid plus base equals water plus salt. A salt, not NaCl always, but a salt. So that's a special double replacement that has water as one of the products and an acid base as the other as the reactants.
Right.
So
So if we remember redox, remember neutralization, you can use your solubility rules to determine if it's precipitation also.
okay, so we can see the overlap here. Neutralization and precipitation overlap. Redox overlaps with precipitation with some single replacement reactions. All right, so remember they don't always have to be just one category.
Easy enough.